This is NeoPixel 213. So what we're going to do here is use almost the same program we just made in the last video. So right now, I'll bring the serial monitor in here so we can actually track it. So right now, if I hit the button, it's going to reverse the direction and go a little bit faster. I'm going to try to keep it within the strip without going over the strip, right? So it gets faster and faster every time I hit it. Oh, didn't do so good. But, well, apparently I did do good according to the serial monitor. But yeah, I got down to 45. Okay, so what we're going to do now is there's an old arcade game where the lights just spin in a circle and you have to hit it at the right point to win the jackpot, to win the amount of tickets, right? And so I'll show you a little video of that. So this game right here in the arcade, lights are going in a circle, and you got to hit at the right point. And apparently he missed it. Well, maybe he missed it, right? This game is slightly rigged. Even if you do hit it at the right point, it's still a random chance. But we're not gonna do that. We're gonna keep it fair here, okay? But basically, yeah, the lights just go in a circle, and as soon as the middle one lights up, you want to hit that button and win the jackpot. We don't have a jackpot, but we can have our serial monitor say something nice or do some celebration with NeoPixels. Okay, so let's go back to our dual view here. Our code right now. Let's fix it up a little bit. So right now, if you go over or under the pixel count, it just says you lose or whatever, right? We don't quite want that. I'm gonna get rid of the serial print, get rid of all this stuff here, all the reset. Okay, isolate this one. If pix is less than 0, dir equals 1 again. If pix is greater than LED count, change the direction back to -1. There we go. Okay. And then the speed, we're just going to keep it constant here. Should we keep it constant? No, we'll speed it. We'll keep it speeding up. That was fun. That was fun to have it speeding up. Okay? And actually, we're not going to go negative again. We're just going to keep going positive. So, we don't actually need any of this. We can do, I talked about this in uh what was it? NeoPixel 211 and 212. Pix percent equals LED count. Okay. So now if I upload this, it's just going to keep going in a circle here, right? Give it a second to upload. Should probably save that program. Whatever. It's been recorded. Okay, so it's going back to this, right? Hit the button and it changes direction. Nope, but it doesn't go the other way because, yeah, I explained that in 212 why it doesn't go the other way. Okay. So if we hit the button, let's figure out a pixel first of all, right? So let's create a variable called const int. We'll call it target, and we'll put it in the middle. Equals pix divided by 2. Not pix, I guess. LED count divided by 2. So if we have 3 LEDs, I guess I'd put it at pixel, yeah, pixel 1. So we have 0, pixel 1, pixel 2. So put it right in the middle. If we have 11 LEDs, so 11 divided by 2 is 5.5. Because it's an integer, it can't hold decimals. It makes it 5. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be right in the middle here. Okay. Okay, so that's our target LED. That's the LED we want to hit when we smash the button. Okay. Now, it turns off a pixel every time we run this thing, right? But we want to know what our target LED is. So what we're going to do here is always keep that pixel on, but like, I don't know, faded. Strip.set pixel color, pixel color, strip.set pixel color, and we want the target, and just like kind of on 40 comma 40 comma 40, right? So it's just going to be a dim white. Let's see if we can do that and see how that looks. Make sure that looks just fine here. All right, so there's a dim. It's a little bright, maybe. I'm going to set it to 25, 25, 25. Okay, next thing we have to do is right now, as I hit the button, it reverses the direction, right? Which was from the old game, but not necessary for this game here. So, direction doesn't change every time, doesn't change the speed, right? So, yeah, it just lashes it and has a little bit of a delay. Okay, so what we do want to do is see if we actually hit the target, right? So if you hit the button, now it's got to check if you hit the target, right? So if pix equals target, then we have to have some celebration and we have to make it harder. Okay? So, first of all, speed, oh, whoops, spud minus equals 7. We're just going to start going faster and faster, right? Okay? And let's see, what else are we doing here? We're setting that pixel back to 0. Oh, we should do some sort of celebration. We'll make that inner one go rainbow. 4 and a equals 0. A is less than 65536. A plus equals 300. 300, there we go. Okay. Start our curlies. So we're going to do a strip dot set pixel color. And I can use target or pix, right? I can use either of these variables because it should be at that point. But I'm going to use target because that's always at the right point. Target, comma, strip dot color HSV A. Okay, so it's going to, oh, and the strip dot set pixel color, parentheses also. Okay, strip dot show. And yeah, how long do we want this celebration to last? So let's bring out our calculator here. Okay, right now, well, we'll see how many increments we'll go through here. So what's 65536 divided by 300? So it's going to run this 218 times. If I wanted to run this for 2 seconds, what I could do is 2000, right? 2000 milliseconds divided by 218 equals 9. So if I did a delay of 9, it should last about 2 seconds, our celebration here. So strip.show, delay of 9. Oh, there we go. Okay. After it's done celebrating, let's reset a bunch of things. Let's see. So inside this, so pix equals 0, start at the beginning. Let's see, speed, not speed. Yeah, that's right. Okay. No, timers, that's right. Okay, so pix timer equals millis plus 200. So give it a little delay to start on. And so that's about it here. So we hacked this program just a little bit to make a whole different game here. Okay. So what it does is every so often, right? Every speed, right now it's set to 150. So every 150 milliseconds, it turns off the previous pixel, makes sure the target pixel is turned on. Okay. Changes, well, yeah, goes up one. We don't need the direction anymore. We could actually make this just a plus plus, but we'll leave that there because it works. If we go over, come back to the beginning like it's doing right there, okay? And set the latest one to a random color and show. Okay, so all it's doing is what we're seeing here, right here. Okay, if we push the button, it's going to latch it, right? So we can't hit it again because if we didn't latch it, we could just hold it till it ran over the thing and then we'd win. But it just latches it so we can't, like it checks it once and then doesn't check it till we let go and hit it again. If we actually hit it at the right point, right? If pix equals target, then ups the speed a little bit, does a celebration, sets the pixel back to 0, and sets the timer back. So let's give this a try. Currently compiling. Let's see if it works. Okay, so I hit it there. Nothing, 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 right? But I wait till it actually gets on it, and yay, it celebrates. Seems a little longer than 2 seconds. Wow, it's just going. Oh, you know why it's going? Let's take a look at our code here. So, a word has a maximum value of 65535, right? 65535 plus 1 equals 0. This will never be above this point. So I messed that up there. What we can do though, just to trick it, just to get that full color rainbow, 65536 divided by 2 equals, so 32,768. 32,768. A plus equals 150, right? And when we do a strip dot color HSV, we're going to do A times 2. There we go. So we halved the increment, half the range, while we still have the range, the word. Oh, and we're using an integer. Also bad. We have to use a word. There we go. So word A equals 0. A is less than half the full range of this and increments up 150 every time. And then we set the color double that range. Let's give that a try. Because the int is only 8-bit, a word is 16 bits. Okay, hit at the right point. There it is. And that's about 2 seconds, right? 1, 2. Yeah, about 2 seconds. Cool. And I can feel it getting faster there. Oh, now I'm starting to miss it. Well, I'm really bad at this now. Oh, there it is. Cool. But yeah, now we have this arcade game where the light spins in a circle. So I could then take the strip, put it in a circle here, right? Or use a ring. And try to hit it. There it goes. Cool. All right, so that's how to turn this one game, the keep it within the lines game, into that arcade ring game. Thanks for watching, guys.